Imagine sitting in a room filled with computer monitors when, without warning, a signal appears unlike anything you've ever seen. It isn't music. It isn't an earthquake. It isn't a submarine. It's a deep, powerful sound rising from thousands of kilometers away beneath the Pacific Ocean. The sound is so loud that underwater sensors separated by vast distances all detect it almost simultaneously. Scientists replay it again and again, comparing it to every known natural and human-made source. Nothing matches perfectly. For years, this mysterious recording became one of the most talked about sounds ever captured beneath Earth's oceans. Some believed it came from an unknown sea creature. Others imagined hidden geological events deep below the seafloor. The internet rumors transformed it into stories about monsters lurking in the darkness. But what do the actual scientific records say? And why is this recording still discussed decades later? Today, we're separating fact from fiction as we explore one of the most fascinating audio mysteries ever recorded. Beneath the ocean, the truth is far more interesting than the myths. And by the end of this video, you'll understand why one unexplained recording continues to challenge scientists while reminding us just how little we truly know about the deepest parts of our planet. Part 1, The Day the Ocean Spoke, 035-240. Our story begins in the late 1990s, but the technology behind it was originally built for an entirely different purpose. During the Cold War, governments deployed sophisticated underwater listening systems across vast areas of the world's oceans. These networks were designed to detect submarines by listening for low-frequency sounds that could travel incredible distances through seawater. Unlike sound moving through air, low-frequency waves underwater can travel thousands of kilometers with surprisingly little loss of energy. That makes the oceans one of the most efficient environments on Earth for carrying deep sounds across enormous distances. In the summer of 1997, scientists monitoring one of these systems noticed something unusual. On multiple underwater sensors, they detected an extremely powerful, low-frequency signal originating somewhere in the remote South Pacific Ocean. The sound lasted for about 1 minute. Its frequency rose rapidly before fading away, creating a unique pattern unlike most previously cataloged ocean noises. Because of its distinctive shape, researchers gave it a simple nickname, Bloop. The recording wasn't hidden or classified forever. After being processed into a frequency humans could hear, it was released publicly, allowing people around the world to listen to one of the strangest sounds ever captured beneath the sea. Almost immediately, curiosity exploded. What could produce a sound powerful enough to be detected across such an enormous distance? The location only added to the mystery. The estimated source was in one of the most remote regions on Earth, thousands of kilometers from major cities and surrounded by some of the deepest ocean anywhere on the planet. This wasn't an area filled with heavy ship traffic or constant industrial activity. Whatever created the signal appeared to come from an isolated part of the ocean where direct observations were nearly impossible. Scientists carefully analyzed the recording using every tool available. They compared it with earthquakes, underwater volcanoes, whales, ships, ice movement, and countless other known sound sources. Some possibilities fit parts of the signal, but none explained every detail with complete confidence. Instead of declaring an answer without sufficient evidence, researchers did what science is designed to do. They continued investigating while acknowledging uncertainty. That honesty would later become one of the biggest reasons the recording remained famous. Part 2. Why this sound was so different. To understand why the bloop attracted worldwide attention, we first need to understand how scientists identify sounds beneath the ocean. Every underwater event leaves behind a kind of acoustic fingerprint. Earthquakes generate recognizable seismic patterns. Volcanic eruptions produce distinctive bursts of energy. Whales communicate using calls that vary by species but follow biological patterns. Researchers have studied for decades. Ships, storms, glaciers, and even rain each create signatures that experienced oceanographers can often recognize. The bloop didn't fit neatly into any one category. Its frequency changed smoothly over time, almost as though the source itself was changing while producing the sound. It was also remarkably powerful. Estimates suggested that whatever produced it generated enough energy to be detected by sensors, separated by thousands of kilometers. That immediately ruled out many ordinary explanations. Some researchers briefly considered whether an unknown marine animal might have produced it. After all, humans have explored only a tiny fraction of the deep ocean directly, and new marine species are still discovered every year. But extraordinary claims require extraordinary evidence. A biological source capable of producing such an intense sound would likely need to be enormous or possess an entirely unknown method of generating underwater acoustics. No physical evidence supported that conclusion. Meanwhile, the internet began filling the information gap with speculation. Stories about gigantic sea monsters, hidden civilizations, or mysterious creatures spread rapidly online because they were exciting. But excitement isn't evidence. None of those claims were supported by scientific observations, recovered specimens, or repeatable data. Researchers instead focused on explanations grounded in physics and geology. They continued comparing the recording with natural processes occurring in Earth's polar regions and beneath the ocean floor. The mystery wasn't that scientists had stopped looking. The mystery was that nature sometimes produces events so rare that understanding them takes years of additional observations, new technology, and careful analysis. And in this case, patience would eventually reveal an explanation that was every bit as fascinating as the mystery itself, while still leaving room for questions about the incredible forces constantly reshaping our planet. Beneath the Waves. Part 3. The explanation that changed everything. For years, the bloop remained one of the internet's favorite mysteries. Every few months, a new theory would emerge, claiming the recording had finally been solved, or that it proved something extraordinary was hiding beneath the Pacific Ocean. But unlike online speculation, scientific investigations rarely end with dramatic announcements. Instead, they rely on years of gathering evidence, comparing observations, and testing competing explanations. As more data became available, researchers began noticing something interesting. The characteristics of the bloop closely resembled sounds recorded near Antarctica when enormous glaciers fractured, or massive icebergs scraped against the ocean floor. These events release incredible amounts of energy. When thousands of tons of ice suddenly crack, shift, or collide, the resulting sound waves can travel vast distances through seawater. Unlike ordinary surface noises, these deep, low-frequency sounds can cross entire ocean basins. Scientists compared the bloop with later recordings of similar ice-generated events. The patterns weren't identical, but they shared important characteristics. The location of the bloop also fit this explanation. Although the sound was detected in the South Pacific, its estimated source was consistent, with regions influenced by Antarctic ice activity. This didn't mean the mystery had vanished overnight. Science doesn't usually deal in absolute certainty, especially when investigating a single event that happened decades ago. Instead, researchers evaluate which explanation best matches the available evidence. In this case, large-scale ice movement became the leading hypothesis because it explained the sound without requiring unknown animals, secret technology, or extraordinary assumptions. That distinction matters. A scientific explanation isn't chosen because it's the most exciting. It's chosen because it best fits the observations, while remaining consistent with what we already know about physics, geology, and Earth's climate systems. Yet even after this explanation became widely accepted, the bloop retained its legendary reputation. Why? Because the original recording captured the imagination of millions before the scientific interpretation reached the public. Movies, books, games, and internet forums continued, portraying it as evidence of hidden creatures lurking in the abyss. The reality, however, is no less fascinating. Imagine a block of Antarctic ice larger than an entire city slowly fracturing under immense pressure. The energy released can produce sounds powerful enough to travel thousands of kilometers beneath the ocean, reminding us that Earth's natural processes often rival anything our imagination can invent. Part 4. Why the deep ocean still holds secrets. Even if the bloop was most likely caused by Antarctic ice, it raises an even bigger question. How many extraordinary sounds are still waiting to be discovered? The oceans cover more than 70% of Earth's surface, yet scientists estimate that much of the deep sea floor remains only sparsely explored. The deepest regions exist under crushing pressures, complete darkness, and temperatures only a few degrees above freezing. Sending research equipment into these environments is technically difficult, expensive, and time-consuming. That means scientists often hear the deep ocean long before they ever see it. Modern hydrophones, highly sensitive underwater microphones, constantly record earthquakes, volcanic eruptions, whale songs, underwater landslides, glacier movements, and countless other natural events. Every year, researchers identify new acoustic patterns that improve our understanding of how the planet works. Some sounds are immediately recognizable, others require years of investigation, and occasionally, a recording appears that reminds everyone how much remains unknown. This uncertainty isn't a weakness of science, it's one of its greatest strengths. Rather than inventing answers, researchers openly acknowledge when more evidence is needed. That willingness to revise ideas as new information becomes available is exactly how scientific knowledge grows. The Bloop illustrates this perfectly. At first, it was simply an unexplained signal. Later, additional evidence pointed toward a natural explanation involving Antarctic ice. Future discoveries may refine that explanation even further. That's not science changing its mind because it was wrong. It's science improving its understanding as better evidence becomes available. Meanwhile, the oceans continue producing sounds we've never heard before. Climate change is altering polar ice. Underwater volcanic activity remains active across the globe, and advanced listening networks are detecting more data than ever before. Some of tomorrow's greatest discoveries may not begin with a photograph. They may begin with a sound. The greatest mystery isn't the recording. When people first heard the Bloop, many wanted it to be evidence of something unbelievable, a giant creature, an undiscovered civilization, or a hidden force deep beneath the sea. But the real story tells us something even more remarkable. Our planet is still capable of surprising us. A single unexplained recording captured in 1997 inspired decades of discussion, scientific investigation, and public curiosity. It reminded researchers that even with satellites, advanced computers, and global monitoring systems, Earth still contains environments we barely understand. The deep ocean isn't mysterious because it's filled with monsters. It's mysterious because we've explored so little of it. Every expedition reveals new species, unexpected geological processes, and remarkable ecosystems thriving in places once thought impossible for life. Every recording adds another piece to the puzzle, and every unanswered question pushes science to build better instruments, collect more evidence, and look a little deeper than before. So was the Bloop ever truly explained? The strongest evidence points toward the immense power of Antarctic ice rather than an unknown creature. Yet its legacy remains important because it demonstrated how science approaches mysteries, not by making extraordinary claims, but by patiently following the evidence wherever it leads. And perhaps that's the most fascinating lesson of all. Some of Earth's greatest mysteries aren't solved in a single moment. They're solved one observation, one experiment, and one discovery at a time. If you enjoyed uncovering one of the world's most famous unexplained recordings, don't forget to subscribe to Earth Enigma, because somewhere beneath the waves, inside ancient caves, or hidden deep within our planet, the next great mystery may already be waiting to be discovered.